Hey guys, welcome back to another video, and today we'd be discussing about another descriptive coding problem. So in the previous video we showed you how to solve a descriptive problem. However, in this case we have a very big descriptive problem of which you have to write the code for. Um, and in this video we'd be looking into classes and objects and methods and how we implement all of those things into the code. However, there's a trick to this. In this problem, we would be learning about polymorphism and how it's being used, and also look into runtime polymorphism. And if you haven't have no idea about it, then you can check out my other video on dynamic method dispatch. So let's just get on into the video and let's get on into the question and try to understand what's being asked of us. So initially, the first point says that we have to create a class which is an abstract class. So from the previous videos, we know that abstract classes would have an abstract method. That is what makes that class abstract. And abstract classes do not have any objects created, and any method that extends from an abstract class or makes the abstract class its parent has to override all the methods. So we have to make an abstract class called shape, and which would have this property or this instance variable shape name, which would be of type string, and a method called area. Of course, that method wouldn't have any body, and a toString concrete method. So if we look into the shape class here, which is an abstract class, we have that instance variable shape name, we have an abstract method which doesn't have any body, and we have a concrete method which does have a body, and it returns the shape name. Okay, so moving on to the second point here, we have to create a sphere Java class. So sphere Java file which contains the sphere class, and that sphere class would have a radius instance variable, and its area is given by and it would have a formula for area. So a method that would give us the area of that sphere. And similarly for other so we have to create two more classes. One is rectangle and another one is cylinder. And rectangle would have a length and a width, whereas cylinder would have a radius and a height. And rectangle and cylinder, they both have separate formulas for finding out their area. So if we look into the code of sphere, we can see that sphere extends shape because uh, it's said in the question that sphere which is a descendant of shape. That means that shape would be the parent class and sphere would be the child class, and sphere extends shape. As shape being the abstract class, we have to override the area method which we did over here, and that area method basically returns us the area of the sphere. And we have our own instance variable for sphere class, which is radius, and we have to create a constructor. The constructor would take and radius from the user and the value of the radius assign the value of the given val r to the radius variable. And here we are basically doing super.shapeName equals to sphere. So remember from the child and parent class hierarchy, the child would always inherit variables and methods properties from the parent. So the parent had a variable called shapeName, and as sphere being the child here, it would inherit all the methods, which it did, and the properties, which is in this case shapeName. Now if you do not write super.shapeName, it would still work because during the Java runtime it would see that okay, so there's a variable called shapeName, and that shapeName, it will look into the the child class, and if it doesn't find any, it will look into the parent class. If it's there, then it's completely okay. So I'm writing super here just to give you a better understanding of what's happening here. Anyway, so sphere class, it would, as it extends shape, the parent class, it would have in total of two methods, one area which we are overriding, and another one is the toString method. And we have a constructor. And similarly for the rectangle and cylinder class, rectangle would have like two instance variables, length and width. It has a constructor that takes two parameters from the user, assigns the length and width accordingly, and we put the name, shape name to rectangle here for the rectangle class. And the area is being overridden. It has a different formula. That's why we are returning something different than sphere. So sphere had 3.4 into 3.4 into pi into r square, whereas rectangle has length into width. And similarly, cylinder, the only difference is basically the name of the variables and the formula for the area, and nothing is different. So all of them have the same base width. And if you look into the third point, it says that paint.java, so we have to create a file called paint.java that would have the paint class and would have a variable called coverage and a method that would compute the paint needed. So how do we calculate how much paint we need? So use the fact that the amount of paint needed is the area of the shape divided by the coverage of the paint. So in the paint class, we are creating a paint class that would have a variable called coverage, and we are using another variable which would take an object of the shape class. Okay, so one of the like most important things that you have to look into here is basically that the paint class has like must need which type of shape you're trying to create. It must know that, plus that area of the shape, and based on that it, and the coverage of the shape, definitely. So based on that it would then generate how much paint you would need. So to do that we are basically creating a constructor. The constructor would take two parameters, one of them being the shape that the user gives, let's say rectangle or a circle or a cylinder, and would give the and pass on a parameter which would show us how much the coverage of the paint is, and then we assign these values to the corresponding instance variables. Okay, so we have another method because we are told to create a method that would compute the paint needed, and amount needed is that method. And in the variable paint needed, we do all the calculations. So basically a dot area, and this is where the runtime polymorphism concept comes in, because let's say the user sends us a rectangle as the parameter, so a would represent a rectangle, right? And a dot area, so rather than a dot area this being run, which is an abstract class and doesn't have any body on the first place, it would go into the rectangle class and run this method. So if you are like confused about this, go check out method dispatch, dynamic method dispatch. However, like the concept is very clear. So a is representing the referred variable, referred object, which in this case would be the rectangle. And we would run rectangle.area, which is this method, the overridden one, and would run that and generate the area. Then we divide it with coverage and we get the amount of paint needed. And here we are basically doing a rectangle.toString, which would return the name of the shape and printing out the paint needed, and we are returning that value. So this is all for like 1 to 3. Now for the final part, it's saying us that we need to create a paint things called file, which would be a Java file, of course, and which would have a main method. And I've already written down all of the things. So we are creating three objects of three different classes. So one of them is a rectangle, sphere, cylinder, and passing on the parameters. So what is happening here in this line? So paint users, when creating a new object of paint and passing rectangle and the paint coverage. So it goes into the paint class, comes here, runs the constructor. So A would have deck, and coverage would have 15 because we are passing 15 and deck. So deck is basically our rectangle here, rectangle. And so this is all done, right? Now we are doing user dot amount needed. So we're basically running this method, and this method would do is dec.area method divided by 15. So dec represents a rectangle, and let's say it generates some value 5031 and divided by 15, we would get 46.66, and we are just printing out the amount needed for a. A represents dec.toString. Dec is a rectangle, comes here. It runs the toString method, but there is no toString method in the rectangle class. So what does it do? It goes to the parent. In the parent, we do have a class, a method called toString, which returns the shape name. And the name of the shape for rectangle is basically rectangle. So it comes here, returns rectangle, then prints out is, and paint needed is 46.66. So similarly for big ball and cylinder, we do the same thing and we get the corresponding outputs. So if you guys did somewhat understand what's happening here, so the basic theme of this problem was to make you understand the polymorphism in action, as the amount method computes the amount of paint for various shapes. So we have like one method, right, which is area, but we are using a like overriding area, and uh, one of like the biggest things here is the runtime polymorphism, which is like a dot area, where a is changing based on what is being passed and what is being called. So hope you guys did understand it, and if you have any questions or suggestions, feel free to comment down below, and please do subscribe. Thank you.